Now the historical observation of 1,3-propanediol pathway has been outlined in this slide. In year 1742, Geoffroy has observed the formation of new water-soluble soup after saponification. In year 1731, 1823, 1843, 1858, 1904, 1925 until 1942, various 1,3-propanediol relevant products, for example, 3-hydroxypropanaldehyde, acrylic acid, acrolein, and so on, has been detected gradually to make the propanediol pathway more easily to be outlined. The discovery of 1,3-propanediol pathway has been outlined as in this slide, with reference to Wozniak at 1910. In year 1945, Circle has developed one quantitative method to determine the concentration of 3-hydroxypropanaldehyde using tryptophan and acrolein. This method has been used until now, before the invention of instrumentation method to detect 1,3-propanediol and related products. Shell in fact has developed chemical process to produce 1,3-propanediol using ethylene oxide as starting material. This method has advantages like higher yield of 80%, applying cheap raw material like ethylene oxide. Unfortunately, intermediate 3-hydroxypropanaldehyde or 3-HPA has caused waste handling problem, increased the cost and causing further environmental pollution problem. Shell has developed this process since 1994 when the Cotera, a type of high-quality polymer, has been invented. Repusa 2 has applied catalytic transformation of propylene into acrolein and further hydrated into 3-hydroxypropanaldehyde and later reduced it into 1,3-propanediol. The disadvantages of the Repusa process are that PDO yield of only 43% could be achieved and produced acrolein is very toxic. Although the raw material propylene is not very expensive, but expensive separation process has been applied. Other process of 1,3-propanediol has been outlined as shown in this slide in year 1993, year 2000, and also year 2004, produced by other suppliers and manufacturers. 3-hydroxypropanaldehyde or HPA has various synonyms like beta-hydroxypropanaldehyde, propanol, lutherine, and so on, with CAS number 2134294. 3-HPA exists as monomeric, hydrated monomeric, and cyclic monomeric forms, and we can see in this slide too that various factors could affect the stability of 3-hydroxypropanaldehyde, namely pH, concentration, and temperature. 3-hydroxypropanaldehyde or HPA system has been outlined in this slide. 3-HPA could be produced chemically by echolin or biologically by using glycerol, using the enzyme glycerol dehydratase. 3-HPA could be further converted into 1,3-propanediol by enzyme 1,3-propanediol dehydrogenase. 3-HPA in fact is in equilibrium with its hydrate and dimer form. 3-HPA in fact is also a type of strong antifungal agent derived from cell metabolite. Various conditions of 3-HPA system and 1,3-PPD activity has been shown in this slide. Acidic conditions, acidic and basic conditions, and basic conditions are three conditions used to analyze the 3-hydroxypropanaldehyde system. The challenges for 3-hydroxypropanaldehyde is the determination of optimal equilibrium states towards the formation of 1,3-propanediol from 3-hydroxypropanaldehyde and glycerol, involving glycerol dehydratase and 1,3-propanediol dehydrogenase. Uses of 3-HPA are that filtering in food preservative, especially in dairy product and antibiotic. Glycerol dehydratase or GDH is used to convert glycerol into 3-hydroxypropanaldehyde. Standard enzymatic method to determine GDH activity is by 3-methyl-2-benzothiazolinone hydrazone method. There are three stages involved. Stage 1, prepare the assay composition. Stage 2, termination of enzymatic activity. Stage 3, addition of water and measurement of absorbance in comparison to the standard route. You can take a few seconds to view at the methodology to detect the activity of glycerol dehydratase. Now I'd like to show you the enzymatic conversion from glycerol to 1,3-propanediol. GDH or glycerol dehydratase has EC number 4.2.1.30, used to convert glycerol into 3-HPA, whereas 1,3-PPD or propanediol dehydrogenase with EC number 1.1.1.202 is used to convert 3-HPA to 1,3-PDO. GDH is controlled by gene BCE for DHA gene, whereas 1,3-PDD is controlled by P gene of DHA.